Chinese automakers are going to come here eventually, and they're going to do it regardless of if there's a tariff or not.
Chinese EVs are often more affordable than those made elsewhere. There are a growing number of budget brands. This new EV.
What happens when the student starts teaching the teacher? 20 years ago, Chinese automakers were copying Mercedes grilles so blatantly that journalists ran side-by-side comparison photos to prove it. Today, Wolfgang Egger, the man who designed Audi's most famous cars.
A car is a big emotion, and a car makes us feel. Audi is always the integration between design, function, and the use of materials. And design
leads a 1,200-person design team for the company that used to imitate him. A Chinese battery maker is pouring billions into a factory built specifically to supply BMW. And Volkswagen, after its own software division lost billions and delayed 2 flagship launches by a year, simply started paying a Chinese startup for the technology instead. This is not decline. It is a complete reversal. From copycats to trendsetters. To understand how far the reversal has gone, it helps to remember where this industry actually started. In the 2000s, Chinese automaker BYD built a small car called the F8, later followed by a larger sedan called the S8. Automotive journalists who covered the unveiling did not mince words. The front end of the S8 was widely described as a near copy of the Mercedes CLK class, down to the grille shape and headlight contours. BYD was hardly alone. Other Chinese manufacturers built vehicles that echoed a Porsche Cayenne, a Range Rover Evoque, even a Rolls-Royce Phantom grille bolted onto a considerably cheaper platform. Why would a company with genuine engineering ambition choose to copy rather than compete? At the time, the answer was straightforward. Chinese automakers were working with a fraction of the research budget, a fraction of the brand history, and almost none of the design pedigree that German manufacturers had spent a century building. Borrowing a familiar silhouette was the fastest way to make an unfamiliar brand look credible on a showroom floor, even if the mechanical components underneath rarely matched the ambition of the bodywork sitting on top of them. Western coverage of the period treated this largely as a punchline, running galleries of copycat designs under headlines mocking the practice, rather than treating it as a serious competitive threat. The list of borrowed silhouettes kept growing through the 2010s. One prominent Chinese state-owned brand, Hongqi, unveiled a luxury concept car whose flowing, oversized proportions closely echoed Mercedes-Maybach's own vision concept for the ultra-luxury segment. A BYD crossover later drew its own round of scrutiny for a rear end that mirrored a Lexus SUV closely enough that outlets covering the comparison ran the two photos side by side without needing much additional commentary. None of this was subtle, and none of it was accidental. What that dismissal missed was what the copying was actually building toward. Every borrowed grille and every imitated silhouette was, whether the companies making them realized it consciously or not, an education in what a premium car was supposed to look like, how proportions were supposed to work, and what buyers responded to on a sales floor. The copying phase was not an endpoint. It was market research conducted at scale, absorbed by an industry that was simultaneously investing far more seriously in the parts of the car nobody could see from a photograph. The battery chemistry, the electronics architecture, the manufacturing process. No single hire captures where that groundwork led better than Wolfgang Egger. Egger built his career at the highest levels of European car design. He started at Alfa Romeo in the late 1980s, became chief designer there by his early 30s, then moved through Seat and Lancia before joining Audi in 2007 as chief designer. Over the following years, his responsibility expanded to lead the Audi brand group, overseeing design across Audi, Lamborghini, and Seat simultaneously, one of the more senior design roles in the entire Volkswagen group. What does it take to walk away from that kind of career for a Chinese company still known, at the time, mostly for copying the very brands he had spent his life building? In late 2016, Egger did exactly that, joining BYD as global design director. The move inverted the usual direction of automotive talent migration, and much of the industry read it, at first, like a downgrade dressed up as an adventure. That read did not hold up. Egger has since described the move publicly as the most exciting challenge of his career, citing the freedom to build a design language from nothing rather than protect decades of existing brand heritage. A freedom, he has noted, that a designer joining an established European house with a century of visual history to defend would never realistically be offered. Today, he leads a design team numbering roughly 1,200 people based in Shenzhen. Egger was not the only senior European designer BYD brought in during that period. The company also recruited talent with backgrounds at Ferrari and Daimler around the same time, building an in-house team that looked, on paper, like the design department of a legacy European manufacturer rather than an upstart. The results have been direct and pointed rather than abstract. Egger has personally unveiled BYD compact models, built explicitly to compete against Volkswagen's own ID series electric hatchbacks, presented at the same European auto shows where Volkswagen has traditionally set the agenda rather than responded to it. The copying era had effectively ended the moment the people capable of doing genuinely original design work started working for the company that used to imitate them. The battery war Germany lost. Design is the part of this story people can see. The battery is the part that actually decides who wins. Two Chinese companies, CATL and BYD, now dominate the global electric vehicle battery market to a degree that would have seemed implausible a decade ago. As of early 2026, CATL alone holds roughly 40% of the global EV battery market.
About 40 kW battery with a big fuel tank and mature range extender to balance cost and range. This balance solves it.
And Chinese battery manufacturers collectively control more than 70% of it worldwide. That is not a niche advantage confined to the Chinese domestic market. It is a dominant position across nearly every major automaker's supply chain, including the German manufacturers whose combustion engine reputations were built without ever needing to think about battery chemistry at all. Why does battery market share matter more than horsepower figures or acceleration times to the average buyer? Because in an electric vehicle, the battery is the single most expensive component in the entire car, often representing close to half the total manufacturing cost. And whoever controls that supply chain effectively controls the cost structure every automaker downstream has to build around. BYD's own blade battery technology, built around a lithium iron phosphate chemistry the company popularized at scale, offered a combination of safety, longevity, and cost that pushed rival chemistries toward the margins of the mainstream market. CATL, meanwhile, built its dominance less through a single flashy technology and more through sheer manufacturing scale and consistency, becoming the default supplier that even non-Chinese automakers increasingly had no realistic alternative to. This did not happen because German or American battery science fell behind on the laboratory bench. It happened because China treated battery manufacturing as a strategic national priority for the better part of 2 decades, investing in the entire supply chain, from lithium processing to cell assembly to recycling infrastructure, at a scale that Western competitors funded in comparison almost as an afterthought. The expansion has not stopped in Europe either. CATL has pursued similar manufacturing and battery swapping projects in Southeast Asia, treating each new region less as a separate market to be won individually and more as another node in a single global supply network designed to make its technology the default choice regardless of which continent an automaker happens to be building on. The most striking part of the battery story, though, is not that Chinese companies dominate global supply. It is where they have chosen to build their factories to defend that dominance. CATL already operates a battery plant in Thuringia, in eastern Germany, placing Chinese battery manufacturing directly inside the country most associated with premium automotive engineering. That plant was only the opening move. CATL is now building a considerably larger facility in Debrecen, Hungary, representing an investment of roughly 7 billion euros and a planned annual production capacity of around 100 gigawatt-hours, supported by a workforce expected to reach 9,000 people, built specifically to supply BMW, Stellantis, and Volkswagen with batteries manufactured on European soil. What does it say about the balance of power when the company once accused of copying starts building its factories inside the exact region its cars once struggled to be taken seriously in? Proximity solves two problems simultaneously. It insulates battery supply from trade friction and tariff exposure aimed at goods shipped directly from China, and it gives German automakers a politically palatable way to keep buying Chinese battery technology without the discomfort of importing the finished product from across the world. CATL has also used major German industry events, including Munich's IAA Mobility Show, as a platform to showcase its technology directly to the same audience of European engineers and executives who once viewed Chinese suppliers as a lower tier of the supply chain. That contrast, a company choosing Hungary for its newest, largest plant while still operating an existing facility inside Germany itself, captures something important about how thoroughly the calculation has changed. A decade ago, the question facing a Chinese supplier would have been whether German manufacturers would accept its technology at all. Today, the question is closer to a routine site selection decision, weighing labor costs and regulatory friction the same way any long-established multinational would, rather than treating a foothold in Europe's automotive heartland as a symbolic milestone worth celebrating on its own. A country that spent decades exporting finished cars to prove its engineering credibility is now watching a Chinese supplier build the literal foundation of the next generation of those cars on its own ground, under its own regulatory framework, employing its own citizens to do it. The symbolism has not been lost on the German engineers now working alongside that supply chain, several of whom have described the arrangement in trade press less as a hostile takeover and more as an uneasy but pragmatic truce. One negotiated less around principle than around the simple fact that the batteries needed to exist, on schedule, at a price that made the finished car sellable. The technology gap grew. Battery supply is one advantage. What Chinese manufacturers have done with charging speed is a separate, more visible one, and it is the difference ordinary buyers actually feel behind the wheel. Newer Chinese electric platforms, including the architecture developed by EV maker XPeng, are built around 800-volt electrical systems capable of charging at rates approaching 350 kilowatts.
A 500-volt nominal voltage is simple entry level 800 vehicle, not true 800 VTEC or higher, true 800V platform.
In practical terms, that is the difference between a charging stop measured in tens of minutes rather than the better part of an hour. Why did this particular advantage emerge from a newer entrant rather than from the manufacturers with a century of electrical engineering experience? Because charging architecture is one of the rare areas of automotive engineering where legacy experience offered little advantage, and in some cases, actively worked against incumbents. German manufacturers built enormously sophisticated combustion and early hybrid systems over decades. But 800-volt architecture is a fundamentally different electrical problem, one that rewarded companies willing to design an entire vehicle platform around it, from a blank sheet of paper, rather than adapting an existing combustion-era platform to accommodate a battery. Volkswagen's own electric platform faced a mirror image problem, having been designed around specifications that predated the wider industry shift toward 800-volt systems, leaving it charging meaningfully slower than newer competitors, despite representing an enormous prior investment. For a family planning a long weekend drive rather than a daily commute, the difference between a 15-minute stop and a 45-minute one is close to the entire argument for or against choosing an electric vehicle in the first place. An argument Chinese manufacturers have been winning on hardware terms alone, before either brand's software or styling ever enters the conversation. If batteries and charging speed are hardware problems, software turned out to be the place where Volkswagen's own ambitions collided hardest with reality. In the previous decade, Volkswagen made a significant bet on building its own in-house software division, called CARIAD, intended to develop the digital operating system underpinning navigation, driver assistance, and over-the-air updates across the entire Volkswagen Group lineup. The execution did not match the ambition. CARIAD's development timelines slipped repeatedly, delaying vehicle launches across multiple Volkswagen brands, and owners of the company's early electric models filed complaints, publicly and repeatedly, about slow software updates and unreliable infotainment systems shipping in cars that had already reached customers. The financial toll turned out to be just as severe as the reputational one. Across roughly 3 years, CARIAD accumulated operating losses well above $7.5 billion, against total revenue of only around $3.5 billion over the same stretch. Losses large enough to wipe out the combined operating profits of several premium Volkswagen Group brands in a single reporting period. Those losses were not abstract accounting figures. They translated directly into delayed showrooms. The launches of the Porsche Macan Electric and the Audi Q6 e-tron were each pushed back by more than a year because of software failures traceable to CARIAD, a delay serious enough to cost the group's chief executive his job, with new leadership brought in specifically to contain the damage. How does a company with Volkswagen's engineering resources and manufacturing scale end up struggling this visibly with something as seemingly contained as software? Because software-defined vehicles reward an entirely different organizational culture than traditional automotive engineering: rapid iteration, constant remote updates, and a willingness to ship imperfect features and improve them later, none of which came naturally to a company built around decade-long product cycles and rigorous pre-launch validation. Desperate to stop the bleeding, Volkswagen eventually turned to a second outside partner beyond XPeng, striking a separate multi-billion-dollar software and electrical architecture arrangement with American EV maker Rivian for its Western market vehicles, meaning the company that once intended to build a single, unified operating system in-house across all 12 of its brands ended the decade instead relying on two separate outside partners, one Chinese and one American, to do the job its own software division could not. Volkswagen's own chief executive, Oliver Blume, eventually confirmed the company would downsize CARIAD's ambitions considerably, shifting the division's role from an independent developer of proprietary software to an integrator coordinating outside software partners instead, one of the more consequential strategic retreats in the company's modern history, and a quiet illustration of how thoroughly the center of gravity in vehicle software had shifted away from the traditional engineering departments that once defined what a German car company actually did. When Germany turned to China, that retreat from in-house software did not leave Volkswagen without a plan. It left the company looking for a partner, and the partner it chose says everything about how far the balance of power has shifted. In 2023, Volkswagen invested roughly $700 million into XPeng's, a Chinese electric vehicle maker still relatively young compared to the German manufacturer's more than 8-decade history. What began as a modest technical collaboration expanded considerably over the following 2 years. By 2025 and into 2026, Volkswagen moved to license XPeng's autonomous driving software directly for use in Volkswagen-badged electric models sold in China, alongside adopting elements of XPeng's faster-charging electrical architecture. 2 fully electric Volkswagen models slated for the Chinese market are set to run on XPeng's underlying electronic architecture and driver assistance stack, rather than anything developed inside CARIAD, effectively making a Chinese competitor's platform the technical foundation for cars still carrying the Volkswagen badge on the outside. Is licensing technology from a company founded within the last decade a retreat, or simply the fastest route back to competitive relevance? Chang's software and charging architecture were already proven, already shipping in production vehicles, and already popular with the exact segment of tech-savvy Chinese buyers Volkswagen needed to win back. Building an equivalent system internally, after CARIAD's well-documented struggles, would have cost more time and money than simply paying for access to a system that already worked. XPeng's own chief executive, He Xiaopeng, described the deepening partnership as carrying significance reaching well beyond the immediate cooperation itself, calling the current period something close to an inflection point for the entire autonomous driving industry. Industry analysts covering the deal have pointed to a detail worth sitting with directly. In the 1980s, Volkswagen entered China because Chinese law required foreign automakers to partner with a domestic company to sell cars there at all.
Europe's largest car maker, Volkswagen, has opened a new factory in the Chinese province of Guangdong.
4 decades later, Volkswagen is partnering with a Chinese company again, this time entirely voluntarily, because it wants the technology that company has built. Volkswagen was not the only major Western manufacturer to reach the same conclusion around the same time. Stellantis, home to brands including Jeep, Peugeot, and Alfa Romeo, established its own significant partnership with Leapmotor, a Chinese electric vehicle manufacturer considerably younger and smaller than Stellantis's storied constituent brands. The arrangement gave Stellantis both a direct equity stake in Leapmotor and rights to manufacture and distribute Leapmotor-designed vehicles across international markets outside China, effectively renting a fully developed Chinese electric vehicle platform rather than spending years and billions of euros developing a comparable one from scratch. The vehicles sold through that arrangement outside China carry Leapmotor's own name rather than being rebadged as a Stellantis product, an unusually candid arrangement compared to the quieter platform-sharing deals that have long existed within the industry, and one that puts a Chinese brand name directly in front of European buyers, with a legacy manufacturer's distribution network doing the selling. What does it mean when two competitors with almost nothing else in common independently reach for the identical lifeline within roughly the same window of time? The underlying math did not depend on which specific company was doing the calculating. Developing a competitive electric vehicle platform from a blank sheet had become expensive and slow enough that partnering with an already proven Chinese platform simply made more financial sense than the alternative, regardless of which century-old European brand name happened to be attached to the decision. That is a genuinely uncomfortable position for brands whose entire commercial identity has always rested on the promise of proprietary engineering rather than assembled components. And it raises a question neither company has fully answered publicly yet. Once a badge stops guaranteeing that the technology underneath it was actually developed by the company whose name is on the hood, what exactly is a century of brand heritage still worth to the buyer signing the loan? Dealers selling these vehicles have had to adjust their own pitch accordingly, leaning less on the traditional promise of decades of in-house engineering and more on the practical reality that the underlying platform, wherever it originated, now performs competitively against anything else on the lot. When tariffs backfired, European policymakers did not watch this shift happen passively. Facing a wave of increasingly competitive and increasingly affordable Chinese electric vehicles entering the European market, the European Union imposed tariffs ranging from roughly 17% to 45% on Chinese-made EVs.
The European Union has taken a significant step. The new tariff rules are reshaping how Chinese-made EVs enter Europe.
Why did a tariff explicitly designed to keep Chinese manufacturing out of Europe end up accelerating Chinese investment inside Europe instead? Because the tariffs only applied to finished vehicles shipped directly from China. They did not apply to vehicles manufactured inside the European Union itself, regardless of which country's company owned the factory producing them. Chinese manufacturers responded to that structural loophole exactly as any rational business would, committing more than $100 billion collectively toward building factories, battery plants, and assembly lines directly inside the European Union and other tariff-affected markets, converting what was designed as a defensive trade barrier into an incentive for deeper, more permanent Chinese industrial investment on European soil. CATL's Hungarian battery plant, described earlier, is one visible piece of that broader response.
CATL's new battery plant, one of Europe's most advanced EV factories, the $8 billion investment by the world's biggest battery manufacturer.
But it is far from the only one. Multiple Chinese automakers have announced or begun construction on European assembly facilities specifically structured around the same calculation, treating the tariff line not as an obstacle to route around occasionally, but as a permanent feature of the market to be designed around from the outset of every new factory decision. European officials and Chinese negotiators have continued discussing alternative frameworks, including a proposed minimum import price system. Though no replacement arrangement has yet resolved the fundamental question underneath the policy debate, whether Europe can meaningfully protect its automotive industry from Chinese competition, or whether it can only influence where that competition chooses to physically locate its factories. Even a successful minimum price agreement would leave the deeper structural questions untouched. Who owns the factory? Who employs the workforce building the batteries inside it? And which country's engineers actually wrote the code running the finished car? None of this means Germany's automotive industry is finished, and treating this reversal as a simple story of decline would flatten a far more complicated picture. German manufacturers still carry genuine advantages. Chinese companies have not fully replicated deep expertise in vehicle dynamics, decades of safety engineering data, and brand loyalty built over generations that still commands real pricing power in markets outside China. What has changed is the assumption that those advantages would remain permanently unmatched. Can an industry built on a century of internal combustion expertise adapt quickly enough to compete in a category where a decade-old Chinese company now sets the pace on batteries, charging, and software simultaneously? The honest answer is that German manufacturers are no longer trying to answer that question entirely on their own. The partnerships with XPeng and Leapmotor, the willingness to source batteries from CATL rather than continue funding a domestic alternative from scratch, and the quiet retreat from in-house software ambitions all point toward the same emerging strategy. Rather than out-innovating Chinese competitors across every category simultaneously, German manufacturers appear to be choosing which battles to fight directly and which technologies to simply license or import. That is a meaningfully different posture than the one the German auto industry held even a decade ago, when the idea of licensing core vehicle technology from a Chinese startup would have seemed almost unthinkable inside a Wolfsburg or Ingolstadt boardroom. Whether that recalibrated strategy proves sustainable will depend on questions that remain genuinely unresolved. Whether the newly licensed software and shared architectures actually close the gap with buyers who have grown used to faster charging and smoother updates elsewhere, and whether German engineering culture can adapt its own internal processes quickly enough to remain a meaningful partner rather than simply a brand name attached to someone else's underlying technology. The copying years are over. What replaced them is not simple decline, but a far stranger and more interdependent relationship than either country's automotive industry would have predicted only a few years ago. The honest reading of that relationship may be that both things are true at once. A genuine loss of ground in categories the industry once assumed were permanently its own, and a genuine, if uncomfortable, adaptation that keeps the cars still rolling out of German factories competitive rather than obsolete. The student is now teaching the teacher. Egger left Audi for BYD. CATL is building batteries on German soil for BMW. Volkswagen burned through billions on its own software, then simply paid a Chinese startup for the answer instead. Even the tariffs built to keep Chinese factories out ended up pulling more of them in. None of this means German engineering is finished. It means the industry stopped assuming it could win every category alone and started choosing its battles instead. Is that decline, or the smartest adaptation Germany could have made? Tell us in the comments. Hit like if this changed your view, and subscribe for the next investigation.